So welcome everyone. My name is Gabriel Gasque. I am head of outreach at protocols.io, and I'm really happy to be here presenting this introduction to our platform. And before we begin, let me just tell you a little bit about myself. I have a background in experimental neuroscience. I did a PhD and then postdoctoral training. And before joining protocols.io as head of outreach, I was a senior editor in PLOS Biology, the flagship journal of the Public Library of Science. So I consider myself a scientist as well as an advocate for open science, experimental reproducibility, and research integrity. And before we begin with the content of the webinar, we would like to acknowledge that protocols.io main office is located in Berkeley, California, the ancestral and unceded land of the Ohlone people. And we recognize that we have benefited from the use and occupation of this land. And consistent with our values of diversity, equity, and inclusion, we have a responsibility to acknowledge this fact. We also recognize that the Ohlone people are alive and flourishing members of the Berkeley and broader Bay Area communities today. I would also like to share some housekeeping information with you before we delve into the main content of the presentation. As mentioned before, I am recording the presentation and I will share both the recording and the slide deck with all registrants. Also, closed captioning has been enabled in case you want to use it. I will speak for some 40 to 45 minutes, leaving at the end some time for questions, but you can start typing your questions at any moment in the chat or in the Q&A windows of Zoom. And finally, well, this is an introduction to protocols.io, so a rather basic webinar. You can find upcoming, more advanced webinars by going to the URL at the bottom, the first URL at the bottom of these slides, protocols.io/webinars. And the second URL will take you to a link to request a one-to-one demo in which you can ask one of our team members any question that you have about the platform. You can share your screen, they can share their screen, and have a very interactive conversation about your questions. Now, this is what we will be discussing today. So I will go over some of the more general points in terms of the motivations for creating protocols.io to begin with, what our mission is, and how our platform and its functionality can make your work easier and faster, both in the research lab and in the teaching classroom, as well as to increase the reproducibility of your research, both internally and externally. But let's begin by defining what protocols.io is. Protocols.io is a virtual platform for the collaborative development, sharing, and publication of detailed, up-to-date, versionable, reusable research protocols before, during, and after publication of a research article. So protocols.io started in 2014, and we currently have over 207,000 registered users who have created over 20,000 public protocols and over 78,000 private protocols. The public protocols are all open access, which means They are fully searchable and free to read, use, and reuse. And last year alone, these public protocols had over 3 million visitors. We have collected a series of tweets that comment on the difficulties and frustrations of trying to replicate previously published experiments. And as you can read in this example, Daniel, this comes from the field of physics, and Daniel goes from reference to reference, trying to understand how certain devices used in a paper from 2017 were fabricated. And when he finally reaches the original publication in this citation change from 2009, this original publication simply says, devices were fabricated with conventional methods. And this is quite frustrating, and just an example that highlights a widespread problem, which is very often the information reported or included in the materials and methods sections of published research articles is insufficient to allow readers to understand what was done and to reproduce the experiments. As part of the background on why Protocols.io was created, we also like to talk about the Cancer Biology Reproducibility Project, which was a $1.5 million initiative coordinated by the Center for Open Science and by Science Exchange, with the goal of trying to independently replicate almost 200 experiments from about 50 high-profile papers on cancer biology. What the Reproducibility Project researchers discovered very soon after the project began is that it is very difficult to replicate work that has already been published. And there are several reasons why this is the case, but one of them is that the original researchers, those that published these 200 experiments, didn't document in their articles with enough detail what they did and how they did it. So what you see on the screen right now is a screenshot of the Center for Open Science website that summarizes some of the results of the Cancer Biology Reproducibility Project. And as you can see, of the 193 experiments that they tried to replicate from 53 papers, 0% of the protocols, 0%, not a single one, were completely described, which made it impossible to reproduce them without contacting the original authors. But equally striking, when the researchers from the Reproducibility Project contacted the original authors, they also discovered that these original authors did not always could tell how exactly their own experiments had been done. Therefore, the problem of lack of reproducibility goes beyond the lack of adequate reporting in published articles, but also highlights deficiencies in the way researchers keep record of their own experimental protocols for housekeeping. And this is caused, among other reasons, because people move from labs. So students graduate and leave, postdoctoral researchers become faculty elsewhere, and so on. And traditional papered notebooks can be easily damaged, misplaced, and lost, and are difficult to search to find the most up-to-date version of a protocol. Therefore, our founders thought that a cloud-based system for the proper preservation and publication of detailed experimental protocols was needed. So generally speaking, Protocols.io comes in two flavors. So we have a completely free open access repository, which provides unlimited publishing of protocols. Each of these public protocols receives a unique digital object identifier, or DOI, making them permanent and citable. So it is free to create an account in protocols.io and to publish an unlimited number of protocols. And because the repository is open access, it is equally free to come and read, use, and reuse the public protocols. But we also have a premium side that offers everything that the free plan offers, plus an unlimited number of private protocols and private workspaces, premium training, and for the institutional accounts or institutional licenses, a free protocol import service. So if you're interested to find more details about our plans, you can visit protocols.io/plans/academia. And later on in this presentation, I will explain what workspaces are and what the protocol import service works, how it works. Some of you might already have an institutional premium account if your university is a partner of protocols.io. So you can check this by going to protocols.io/for-institutions, and as I show you in this movie, scroll down the page, select your organization, and look if your university is a premium partner of protocols.io. If that is the case, then your access to the platform is also premium. But let's now discuss why we think it is productive, time-saving, and rewarding to create, share, and publish detailed research protocols, in addition to fostering reproducibility. And the key message that I want to convey is that practicing open science, and in this case, open methods, is beneficial not only for the extended research community, but also for individual practitioners. So let me begin by showing how the protocols created and published in protocols.io go beyond what a traditional static PDF offers. Our protocols are live, dynamic, and interactive, yet persistent and citable. So I'm going to be opening one of the protocols created in the platform and published in the open access repository. Because this protocol has been published, it has an assigned DOI, which makes this digital document both persistent and citable. This protocol is actually part and cited in a publication in the journal PLOS ONE. The protocol itself is written with a lot of detail in a recipe-like step-by-step fashion. Steps of the protocol can be enriched or supplemented with images, pictures, and even videos that you can play to clarify certain steps of the protocol. The protocol is an interactive document because any reader can come and post a comment, and the authors will be notified, and they can return to the protocol to respond to that question or comment. Different sections of the protocol can be coded in different colors, creating a table of content that I can navigate. The protocols are versionable, and I can look at different versions of the protocol, and I can even compare two versions of the same protocol side by side. If I find this protocol useful, but I need to optimize it to make it work for my own particular conditions, I can create my own editable copy or fork that will be privately saved in my account, and then I can tweak and modify. And the protocols are also runnable. So I can follow the experiment directly from my computer or tablet. As I complete every step of the protocol, I can mark that step as done. There are integrated timers, and when they finish, the computer will beep. I can add comments to certain steps. If I want to add an annotation, if something looked unusual, or if I made a mistake, or I can even tweak a step as I am performing the experiment. And this will not change the original protocol, it will only change the run record. When I'm done with my experiment, I can just finish the run, and that will create a separate run record file. But let me go back to my presentation. And while there is a historical bias in favor of protocols in biomedicine, the platform itself is agnostic to the research topic, and researchers have begun to use it to develop, share, and publish protocols beyond the molecular biology laboratory. So in this slide, I show you 7 exemplary protocols in the areas of electronic, computational biology, clinical research, systematic reviews and meta-analysis, environmental sciences, archaeology, and social sciences. And I'm going to open one of these protocols for you to see. So this is a protocol in archaeology that describes a tool to create illustrations out of lithic tools. And again, as you can see, it has different sections. It is very detailed, step-by-step, recipe-like fashion. It is supplemented with images and pictures. It has an assigned DOI, as the authors have published 3 versions, and it is runnable and forkable, just like any other protocol in the platform. Now, let's discuss about the benefits, the rewards for creating and publishing any of these detailed experimental protocols. So not necessarily in order of importance, but a first advantage of making your detailed methods public is that by using specialized repositories to publish your protocols, you are increasing the chances that they will be discovered and reused, which should lead to more credit and recognition. So let's use another example that I took from X, or previously Twitter. So you can see here a tweet from a researcher who was looking for a protocol for RNA extraction from primary cortical neurons in culture. Someone answered this tweet and recommended a protocol that is in protocols.io. But the funny thing is that this protocol was actually part of a paper that was published in the journal GigaScience. Now, the paper is about a fish parasite. So the chances of researchers working on primary cortical neurons in culture finding a paper on a fish parasite as means of finding a protocol that would work for them seem really slim. But because the protocol was published independently in a specialized repository, it made the method more discoverable and increased the chances of people reusing it. And once a protocol is published, the document has a tab that is called metrics that shows all the traffic and use of the protocol, including number of views, number of bookmarks, exports, copies, comments, and citations that the protocol has received. Another reason to make your protocols public is to guarantee preservation and to facilitate the seamless continuity of the work inside your own laboratories. As we have discussed, a large fraction of a lab personnel is floating. The students graduate, the postdoctoral find positions elsewhere, and so on. So publishing your protocols makes them persistent, citable objects that will be permanently stored both in your workspace as well as in the open access repository. And I should mention that all private and public content in protocols.io is mirrored and backed up in Clocks, GitHub, and the Internet Archive. Public sharing of protocols also could potentially increase the chances of establishing collaborations, as we have seen cases where researchers report that this is the case. And I would like to show to you how the comment functionality that I briefly explained before allows an open, scholarly, and productive discussion between all parties interested in a particular protocol and method. So I'm going to be opening another public protocol. This is a protocol of a very popular method. Again, this protocol is a detailed method, step-by-step, recipe-like. But the point that I want to highlight here, is that this single protocol has received over 13,000 comments. Sorry, 1,300 comments. Right? 1,300 comments. And I can see all the conversation between readers and users of the protocol and the authors responding to those comments and questions. The comments can be made at the step level or at the protocol level. And you can imagine how this scholarly, open conversation could potentially lead to collaborations. Managing and publishing your protocols should also simplify your work down the road when the time of submitting and publishing a paper comes. I'm going to use another example from Twitter. So here we have Professor Jonathan Kipnis at the Washington University in St. Louis, who tweets and says, "What if labs publish each of their unique methods protocols, and in future papers, which instead of rewriting the protocols, we just cite them?" And then he adds, "We waste so much time on methods by saying the same thing differently." And that is exactly what protocols.io is about. You can publish your updated, detailed research protocols in the open access repository, obtain DOIs, and anyone, you or your colleagues, can cite those protocols. But citing detailed protocols goes beyond saving time by not rewriting methods. Citing and using detailed protocols improves rigor and reproducibility, making your papers more robust and impactful. And this is what the authors of this PLOS Biology paper did. They created and published their protocols in protocols.io, obtaining a citable DOI, which they then included in the materials and methods section of their paper, replacing most of the writing. Now the reader, by following the link highlighted here, has access to the detailed methods. And a really nice thing about how protocols.io works is that the protocols are versionable, as I mentioned before. So if the authors have updated their protocol since the time of publication, if they made a correction or if they optimized a step, the reader will be notified, as you can see it on the screen right now. And they can choose to read the protocol as it was published together with the paper, which is what you see on the screen now, or by following the View the Newer Version link, read the most updated version of the same protocol. And a fifth point would be that by managing and preserving and archiving your protocols in protocols.io, you will be complying with the NIH data management and sharing policy, because methods are an integral part of data. And the NIH's rigor and reproducibility guidelines also explicitly highlight the need for grant applicants to describe details in their applications. And these details should be considered by the reviewers. And as a bonus, by practicing open science, and in this case open methods, you increase reproducibility in the field, which you can see as a present, as a gift to your colleagues and the extended research community. But you also increase the reproducibility within your own team of research, which is a present to yourself. And in a push to increase transparency, accountability, and reproducibility, several organizations, including over 500 scientific journals, funding agencies, and educational and research institutions across 3 continents, support and promote the use of protocols.io. So now let me give you a very basic taste of how the platform looks like and how its different functionality allows you to do everything that I listed before. Organize and preserve your work, collaborate, save time, increase your reproducibility, impact, and credit. So protocols.io, the platform, has 3 main sections: the workspaces, the file manager, and the editor. And I will explain in the next few slides how they relate to each other by using a simple cartoon. So the workspace is where everything happens. It is from this workspace that you create protocols, organize your work, and collaborate with others. The workspace has a folder that is organized by the file manager. And in the file manager, you can use the editor to create protocols. So during my explanation on what each of these features or sections does and how they relate to each other, I will be moving back and forth between them. So if you go to our website, what you see on the screen now is a landing page. So you can create an account if you have not done so already and log in. You can also log in using Orchid, Facebook, or Google. And once you start a session, the system will ask you to create a workspace. This is the first step. You need a workspace to work in protocols.io. You can also invite, at this point, collaborators to join this, your first workspace. But inviting colleagues is not compulsory for you to proceed. Once you have created your first workspace, this is what you will see. You will have access to the file manager, which in this case is empty because the workspace is new. To your left, you have access to the administration menu of the workspace. And to create a new protocol, you go to the new button, and that will take you to the editor. The file manager will eventually contain, display, and organize the protocols that you have created in that workspace. The file manager supports any file type, so you can bring PDFs, Word documents, in addition to the protocols you are creating with the editor. It helps you archiving, auditing, and exporting because it can connect to Dropbox, OneDrive, and Google Drive. So you can move your documents between the platform and any of these cloud-based drives. And the file manager has been designed with enterprise-grade security and backup functionality. So all your documents are not only safe, but also private. Now, the editor, which is the tool to create protocols, has detailed components, a granular editing history that allows you to see all changes done to a protocol and revert them if necessary. The editor also allows concurrent editing by two or more collaborators, the same way that two or more people can work simultaneously on a Google document. As I mentioned multiple times, the protocol is written in a step-by-step format, and different sections of the protocol can be coded in different colors. Now, going back to the workspace, this is the space for collaborations. So you can invite anyone to join your workspace. It can be a student or a postdoc, another faculty member in the same institution, or external collaborators. To invite collaborators, you go to the administration menu of the workspace, which is to the left. You select Manage Members, and now you can start inviting people by just typing their email address. They will have to create an account in protocols.io to join your workspace, but as I mentioned before, creating accounts is free. You can make your workspace public, which means that it will be searchable and people can request to join, or make it completely private, which is the default setting. So everything that you create in protocols.io starts privately, a workspace or a protocol. And you have to take steps for make those public. You can also manage the privileges, the permissions that the members of your workspace will have, and you can limit what they can do, such as inviting other members or sharing or deleting files from the workspace folder. Workspace members can comment on the protocols you have created and share with them, or ask questions by using the comment functionality that I've showed you before. Members of a workspace can also make changes to a protocol. And as I showed you before, there is a log that keeps track of all changes in a protocol, which can be reverted if needed. Members can also create their own protocols in that workspace, and you will have access to those documents. Or they can take an existing protocol, make a fork or editable copy, and optimize it for a different purpose. The platform also allows you, sorry, the movie is not working now, but the platform also allows you to compare side by side two versions of a same protocol. And even if a member of your workspace leaves, because, for example, a student has graduated, the protocols will remain organized, up to date, and available in the file manager. So they are not taking the information with them. It remains in the workspace. You can also export protocols as PDFs. So you can take any protocol and export it as a PDF directly to the printer or to your computer. This is just a test protocol, but this is how the PDF will look like, and then you can print it. But in this case, this protocol is empty. Now, you can also collaborate beyond your workspace by sharing your protocols with specific people, or via email, or by publishing them. So again, I'm going to go to my file manager. So this is my own private workspace. And you can see that I have a series of folders and loose protocols. If I want to share a protocol beyond my workspace, I can select any protocol. I can share it, and I can send this protocol to specific people beyond my workspace. And when I add collaborators to this specific protocol, I can tweak what they can do with my protocol. In this case, Lenny and Emma can edit my protocol, but Nastya can only view it, but I can change the privileges at any time. Now, publishing a protocol will assign to that protocol a DOI and will allow anyone with an internet connection to search for it and to access it. It becomes a public document. A published protocol with an assigned DOI is a citable object that can be referenced to in a paper, as the authors did in this case. The reference will be linked to the detailed protocol in protocols.io, so the reader will have access to the interactive step-by-step method, even if the paper was published behind a paywall. And that's because all of our public content is open access. Once a protocol is published, any reader can create a new fork or editable copy and modify that protocol according to their own needs. In that sense, all public protocols, because they're open access, are templates for further optimization. And you can achieve that with only one click. Now, the platform will maintain the line of credit. So everyone, the original creators and the optimizer, will receive credit. And this is an example. So we have here a protocol that is a fork from an original protocol created by somebody else. The platform clearly indicates that this protocol was forked from another protocol, which the reader can access by following the link. So all creators receive credit for protocol creation and optimization, and the reader has access to the history of changes and evolution of the protocol. Another way for you to share your protocols and to increase your credit for your method development is to send the protocols for peer-reviewed as standalone methodological papers to PLOS ONE, Nature Protocols, BMC Methods, Lab Animal, Biotechniques, or Gigabytes. Protocols.io itself is not a journal, so we don't peer review the protocols. However, we partner with these 6 journals where you can get your protocols peer reviewed as a standalone papers. It is your choice, but we give you the option to get your protocols peer reviewed. And this is how they will look in the platform. So once you have a protocol, you have a button that is called peer reviewed options, and you can select any of these 6 journals to have your protocol peer reviewed. Each journal has a different peer review process, has a different scope, so it is for you to decide. Now, going back to the workspaces, you can create multiple workspaces in your account depending on your research and teaching needs. So you can create workspaces for different research projects or to teach different courses. Each workspace can have different members and contain different protocols and documents, giving you great flexibility for organization. So I appreciate, however, that you might already have existing protocols in different formats like Word documents or PDFs. So in the last 5 minutes or so, I will do a live demo to show you how you can bring those digital protocols into protocols.io. So I'm going to show you 4 ways, going from the easiest to the most complex one. So I'm going to minimize my screen. Sorry. I'm going to go back to my file manager. As you can see here, I have multiple workspaces, but I'm going to be using my own private workspace. And I'm going to create a new folder with today's date. This folder is empty. And you see here my hard drive that contains a few protocols in different formats. So I have a PDF, I have a couple of Word documents, a text file. Just going to open the PDF for you to see. And this is just a traditional protocol with a title, an abstract, and then different sections and steps. The easiest way for me to centralize all these existing protocols is just to drag and drop them. Now the protocols have been copied into the platform. The members of my workspace will have access to those documents. I can share them beyond my workspace, as I showed you before. However, these are not publishable documents because they are not protocols. They're just documents in their original format. For me to create a publishable protocol that has all the functionality of the protocols created with the editor is to select this document, the one that I want to transform into a protocol, and use an AI-powered tool to make the protocol into a protocols.io document. So I can highlight the protocol that I want to transform. In this case, I'm going to use this Word document that is called test protocol B short. I'm going to create using AI. And while it works, I'm going to show you how the Word documents look like. So this is the protocol that I'm going to be using. Again, simple, a title, an abstract, and a couple of sections. That's the Word document. The AI tool has finished its work. Now I can view the protocol. And you can see that the Word document has been transformed into my protocol with all the functionality. It can be copy and fork, it can be run, it accepts comments, and now I can publish it and get a DOI. If you don't want to use AI, there is a way for you to directly insert steps from text. So this is the protocol that I created. So I can open it. And instead of using AI, I can insert steps from text. And now from my Word document, I can copy the steps that I want to insert. Paste them here, preview, and I can add them to the protocol. And now the steps have been added. So we have an AI-powered importer, or we have a text parser. And you can do a combination of both or choose one. And again, now this protocol is publishable. And finally, we have an entry service. So by going to protocols.io, we enter protocols. You can send us your PDFs or your Word documents. And we have a team of editors that will create the dynamic and interactive protocols for you. Now, this service comes at a cost, but it is free for members of partner institutions. So in summary, I hope that I have provided enough information to persuade you that by practicing open science and open methods with protocols.io, you can stay organized, collaborate efficiently, save time, increase your impact, and get credit for your method development work. And with that, I will be happy to take any questions. And I saw that people have started typing them in the chat, Q&A windows. So the first question is whether we have a template for wet lab protocols. We don't have templates for wet lab protocols, but you can search in the platform for any keyword. So if you go to the home page, you can search for, let's say, PCR. You will find protocols that have the keyword PCR. Some might be good, others not so much, but you can select any protocol, see if this protocol will work for you, and then you can create your own editable form, which then you can optimize. So any public protocol is a template for further optimization. The way to start a protocol from the scratch is once you have created an account and you have a workspace, which I will show you, it will start empty. My workspace is pretty populated. But if you create your new workspace, so I just have created a new workspace, it's empty. The way to create a new protocol is by selecting the new button. Sorry, now here. I will go to the folder, and then you can create a new protocol. And then you can start adding to the protocol a title and start adding a new section if you want to add sections, and then steps. Step 1, step 2, a new section, section 2, and so on. So this is how you create protocols from the scratch. There is a very long question that by Larissa Pruner, that I'm gonna save at the end. I'm gonna get to shorter questions. Where do I find the different sections, steps, materials, guidance, etc., or do you have to create them? So I'm showing you right now how to create a protocol from the scratch. So I just added sections and steps. If I go to the view, I'll see how it would look like. I go back to the editor. And then here you have the different tabs. So you have a description tab where you can add an abstract. This is the abstract. You can add authors, keywords. There is a guideline and warning tab. There is a tab for reference and a tab for materials. If you send the protocol to peer review and it's rejected for some reason, does that impact the protocol on protocols.io? No. If your protocol is rejected as a paper, it doesn't affect the protocol that you have published in protocols.io, and it won't be indicated that the protocol was rejected. Can you edit the protocol uploaded by AI? Yes. So again, I'm going to go to the file manager. This is a protocol that I uploaded with AI. And now I can open it. And from the editor, I can edit it. I can add text, right? I can delete text. I can insert tables. It is fully editable. And now I'm going to read the long question. So it says, recently I came across protocols.io through BMC, and it seems like a good platform for sharing our work. However, I have two questions. protocols.io appears to be well suited for clinical trial protocols. Would it also be appropriate for publishing other types of protocols which focus on research process mapping? Any protocol that can be described in a step-by-step fashion can be published in protocols.io. And the second question is, given our goal of disseminating these protocols widely, would it be preferable to publish them through a peer review process instead? So there is no right or wrong answer to that question. You can do either way. You can publish your protocol in protocols.io. We don't peer review it. However, once a protocol is published, like this one that is here, there is a works for me button. So if that protocol works for people, they can click this button, or they can also add comments if something is not working for them. And at the same time that you are sharing your protocol in the open access repository of protocols.io, you can send that protocol to be peer reviewed as a standalone methodological paper. So you can do both. And there is no reason why you shouldn't be doing both, right? You can get your protocols peer reviewed and published as a paper, and you can share it right away in the platform. Now, the journals are peer reviewed, but there also is a slow process. And once the protocol gets published, it's just a PDF. And you can see from all the functionality that I have shown you that the platform offers much more than a PDF. You can receive comments directly on the protocol. People can make forks of the protocol, and you can keep versioning the protocol as the protocol evolves. So I think that I addressed all the questions, but let me know if you have any other. As I mentioned before, I have recorded the presentation, and I'm going to send a copy of the recording to all registered participants. I know that I shared a lot of information, so you might need some time to digest. And the slides will also be shared with you. And you can see on the screen my email address, so feel free to email me later on if you want, if you have a question in the future. And Larissa, I have your information. So I will look at the protocol that you shared with me, and I will give you more thoughts. Okay, if there are no other questions, I will finalize the presentation now. And thank you so much for your participation today.